In section 9.2, we're going to look at linear regression. In 9.1, we learned how to determine if a linear correlation existed between two variables. Now we will find the equation of a line that best models or best fits the data. This line is called the regression line, or the line of best fit. After we determine the equation of the regression line, we'll use it to predict a value of y for a given value of x that is in the range of the data. Okay. So for us, the equation of regression line is going to be first of all, it's a line. So it's like your y equals mx plus b that you're used to in the past. Here we'll kind of use the notation y hat because it's a regression line. So we use y hat equals mx plus b. The calculator, instead of using m and b, they just refer to it as a and b. So it's going to be y hat equals ax plus b, where as you're used to, the coefficient of x is the slope of the line, and the constant term, the b, will be the y-intercept. Let's look at some examples here. For example, let's construct the scatter plot and draw the regression line. We will also find the equation of the line of regression, and we'll use the regression equation to calculate the value of y for each given x value if it's meaningful. In this data set, we have a relationship between hours spent online the day before a test and this test score a student gets on the exam. First things first, we want to go ahead and enter this data into the calculator. So I would again go to Stat, Edit. We always want to put our independent variable, that should be the x values, should go in the first column. So it'd be 0, 1, 2, 3, 3, 5, and then it kind of continues and wraps around, down around here, continuing on 5, 5, 6, 7, 7, 10. The related y values, which are the test scores, would be 96, 85, 82. So we want to go ahead and get all of our data points in. And then the thing that's nice is that there's really no new commands with this. So the same linear regression that we used last time in order to get the R value, the correlation coefficient, will also give us more information we didn't focus on last time, but it will actually give us the coefficients of the regression equation. So let's go ahead and go back. Let me do stat. We want to calculate, and we want to calculate a linear regression. Again, everything should be as it was before. We want to have the x list, our independent variable should be L1, our y list should be L2. Something new that we're going to do here, though, that will kind of help us out in a little bit, is we're going to get this regression equation, and we're going to do some things with it. So I want to store this under my y equals menu. In order to do this, you can go down to the option where it says store regression equation, and I'm always going to store it under y1. So to do y1, you would go to the vars key. So I'm going to hit vars. I'm going to go over to yvars. This is a function. And the function we want to plug this under is we want to plug under y1. So to store your regression equation, again, those steps were, again, hit vars. Scroll to the right to do yvars. First option is function, and then go ahead and hit y1, and that will store the regression equation in y1. We go ahead and hit calculate, and here's what we get. We have an R value of negative 0.831, so it is a negative linear correlation. It's not too strong, maybe moderate we might want to call it, because again, it's not too close to -1. It's not even negative 0.9 or lower in terms of value, but it's not too bad. So maybe a moderate negative linear relationship here. The regression equation, the new thing in 9.2, is this equation here. The calculator reminds us that it's going to be of the form ax plus b. So this is our linear regression equation. And directly below it, it tells you the value for a, which is the coefficient of x, and it tells us the y-intercept, which is the value for b. So our regression equation, rounded to 3 decimal places, would look like this. It's the equation y hat equals negative 4.067x plus 93.970. So this is our regression equation. Because we stored it, if I just simply go to graph, and then I'm going to do my zoom standard, or excuse me, my zoom stat, not only will it graph for us the ordered pairs here. So we see our scatter plot diagram is being done, but in addition to that, it has also plotted our linear regression line, which is the line of best fit, meaning this is the straight line that best models or approximate that data. Again, as we said, just based upon the R value, looking at it, it does kind of follow a general downward trend. The points aren't too far enough apart so they're fairly close to the line. So it is a moderately strong negative linear correlation. Okay. And that's we can see not only from the R value, but simply by also looking at the scatter plot and seeing how that line of best fit would model the overall data set. We can use this linear regression equation in order to make some predictions of some certain x values. Okay? The thing to keep in mind is that in terms of our prediction equation, it's only going to be valid for values of x that is in between data sets that we have. So if I go back and look at my table, so I have values like 0, 1, 2, 3, 3, 5, all the way up to 10. The smallest such value is 0. The largest such value is 10. So this regression equation that we have would be valid for x. I can plug any x value in here that's between 0 to 10 because that's the values for which we have data for. It's unreasonable for this kind of trend to carry on forever and ever and ever, but we would expect it to be at least somewhat reliable within the data that we have collected. So for example, if I wanted to predict what would be the test score for somebody that spent 4 hours online the night before, all I would do is simply everywhere I see an x, replace it with 4, and we would get the following. Y hat equals negative 4.067 times 4 plus 93.970. You would just kind of go ahead and calculate order of operations, multiply and then add, and we would get an expected test grade of around 77.702. Similarly, if I were to plug 8 in, what would be the expected grade for somebody that spends 8 hours online the day before? You would do negative 4.067 times 8 plus 93.970, and that would give us a predicted test grade of about 61.434. One of the conveniences, in addition to seeing the graph of the line of best fit along with our scatter plot, is the calculator will also allow us to kind of calculate these predicted values. Because if I look at my y equals, that regression equation thankfully was stored for us under y1. So when we're looking at the graph, under the graphing feature, there's the ability to do a calculation. And the calculation button is going to be the second trace key. So if I can do second and then trace, this will allow us to calculate. And in particular, I want to calculate a value here. And now the calculator wants to know, well, which value of x do you want to calculate? Well, let's go back and double check. We said that when x was 4, the predicted test grade should be a 77.702. And sure enough, if I plug that in, when x is equal to 4, we get 77.7, well in this case 700. Reason for that being that the calculator, when we store it, it's going to carry all of those values all the way down. We kind of rounded to 3 places. Okay? But it's not going to be enough to be anything significant. Similarly, if I wanted to do the calculator for the calculation of 8, I would again have my graph, or you can just do second calculate. I want the value when x equals to 8. I hit enter. And again, you would get a predicted test grade of about 61.43, 61.43. Let's do a new one. What if somebody spent 9 hours online the day before a test? Second calculate. The value of this prediction equation at 9 would be 57.36. 57.36. One of the things that's nice about the calculate feature is watch what happens with this. If I try to do second calculate the value at, let's say, 15, second calculate the value when x is 15, I get an error, an invalid dimension. And if I pause for a moment and think about, well, what's going on here? Let's go back to what we said at the very beginning. This regression equation is only valid for x's within the data that I have, meaning between x from 0 to 10. Because this x value of 15 falls outside of that range, the prediction value is not going to be meaningful. You got to be very careful with this. As an equation, if I just take this thing out of context, I could plug 15 into this, multiply it, and then add the 93.970, and I would get a value. But the problem is that that value would not be meaningful and is unreliable in terms of our linear modeling. So be very careful whenever you're trying to evaluate a prediction equation. It's only valid for x's ranging from the smallest x value to the largest x value that you have. Anything that falls either below or above that, we will say that that value is not meaningful, and you should not be plugging those values into the prediction equation. Let's do one more of these. Let's take a look at the relationship between the calories an item has and the number of grams of sugar of the item. So independent variable will be calories. The dependent variables will be the grams of sugar. So I need to input this new data set. I'm going to hit stat, edit. I want to clear off these two. So we're going to clear them off. I'll start by entering my independent variable x in the L1 column. That's 140, 200, 160, 170, 170 again, 190, 210, 190, 170, and then 160. We now are going to enter the corresponding y values in order: 6, 9, 6, 9, 10, 17, 13, 18, 19, 10, and 10. The next thing I'm going to do is I want to do a stat. We're going to calculate. Okay, we're calculating the linear regression. X's we put in L1, the Y's we put in L2. We never really need to touch the frequency list, so we're not going to bother with that. But once again, it's convenient and helpful. I want to store my regression equation so I can use it for this data set. To store the regression equation, again, the command is you go to vars, go over to yvars, under function, and then simply we're going to put it in y1. You can go ahead and hit calculate. This gives us our regression equation. The thing that's convenient is the calculator will always kind of remind you the form of it. So it's going to be y hat equals a is the coefficient of x, so it's going to be 0.167x. The b value is negative 18.1, okay, or negative 18.140. So this is our regression equation. If we look at the r value, r is about 0.749, which is a, it's not great, it's not high, but it's a moderate linear positive correlation. If we want to take a look at the graph of this thing to kind of witness it, just again go to your zoom. It's a new data set, so we have to reset the window by doing a zoom stat. So middle button zoom, choice 9. And not only do we get the data set, but because we stored the equation, we will also get the line of best fit on the same graph. So just kind of looking overall, again, the data points do tend to be moving upwards as we go from left to right, so that makes it a linear relationship, but they're not always too close together, so there's a little bit of variability, so it's a moderate linear positive relationship. And this would be the line of best fit that best models those data points. We can now use this line to do some predictions. If I go back and look at kind of the range for the x values, so the x values we used here, the smallest of which was 140, the largest of which was 210. So this regression equation would also come equipped with kind of a set of inputs that are going to be between 140 and 210. Anything in between that we can plug in and get a meaningful result. Anything either less than 140 or more than 210 would not be meaningful. For example, 150 would fall in that range, so we can do a prediction. Everywhere I see an x in my regression equation, I would put 150. This is going to be 0.167 times 150 minus 18.140, which would give us 6.9. So an item that contained 150 calories, we would expect it to have around 6.9 grams of sugar. Again, how can we get that in the calculator? Well, as long as your regression equation is stored, you would want to go to second, calculate, the value. The value of our regression equation at 150, hit enter. That's going to give you that 6.9. In this case, 6.97 again, because that calculator, when we store the regression equation, it stores all of the digits of A and B. But again, for us, round off error, it's not that far off. Certainly, it's always better to be more accurate. Got to be very careful. If x equals to 90, that's not in the range. The smallest we could plug in would be 140. So the x equals to 90 would not be meaningful. If I tried to calculate it, let's say if I wasn't paying attention, and I tried to plug in 90, the calculator kind of reminded me, it's like, oh, wait a minute, that's a no-go. That's not in the range here. When x equals to 175, you can either plug it in or do second calculate the value. 175 would be in the span of x, so we can use that. If it had 175 calories, we would expect around 11 grams of sugar. And then lastly, 208 is less than our maximum, so it's in the range. So we can do second calculate the value at 208 would be about 16.69. So if the item had 208 calories, it would clock in at about 16.5-ish grams of sugar.